1 to 6, right? 1 to 6. So all the outcomes were stored in this random variable, right? I think you all learned before in this discrete maths, right? Okay, so it's a big X. So all the outcomes were stored in these random variables. So for example, if you roll a dice, then it will be 1 to 6. Okay, so the value of X here, the value here we call as a random variate. So we want to take this value as our random numbers, okay, as our random number. Okay, so when you play a game, computer game or whatever game, okay, for example, there's a waiting time for monster number 1 to come out, right? And then the waiting time for monster number 2. Okay, so this waiting time, they are randomly generated, right? Okay, so how to generate this waiting time, right? So waiting time actually follow these exponential distributions. So let's go into these exponential distributions. So for exponential distribution, there is a PDS. PDF is stand for probability density function. So did you learn this probability density function or not? In your discrete maths. So basically it's a function, okay? So equal to lambda I e negative lambda x. So what is a lambda, right? Lambda basically is an average of occurrences, okay? Occurrences per time, okay? Per time. For example, average of number of customer per minute, okay? So from this PDF, from this function, we can get CDF. So CDF is we use okay, big letter of F, okay? So equal to 1 minus E negative lambda x. Did you learn this CDF before? No. As I know last time, for last time syllabus foundation, they did learn this exponential distribution. But now I'm not really sure. Probably no more. Okay, so this CDF, when you plot the graph, it will be like this. So the maximum will be 1. Okay, so the maximum of probability equal to 1. Okay, so this X is a random variate. So now we want to get this X as our random number. So how to get this X as our random number, right? How to find this X? So first we want to simplify this function. Simplify this function here. So we let R equal to these functions. Okay, simplify the notation. So as a result, R will equal to 1 minus E power of negative lambda x. So how to get this x as our random number, right? So first, we put this E to the other side. It will become positive, right? And transfer this R to the other side, be minus 1 minus R. Okay? So in all, now we need to bring down this x, right? So we apply ln to both sides. So as a result, you can bring it down. So it'll be negative lambda x ln e. So still remember ln e equal to 1. Yes, ln e equal to 1. So as a result, we get negative lambda x. So in order to get x, we transfer negative lambda to the other side. Okay, negative lambda transfer to the other side. And now we want to generate a series of random number, right? So we put in I for the iterations. This I for the iteration. Okay. So how do you use this? So this is the algorithm for us to generate a series of random numbers. So let's go into the example. Okay. Let's see how to generate a series of random numbers. So given move up. Okay, R1 equal to 0.1306. R2 equal to 0.0422. And lambda average equal to 1. So when lambda equal to 1, here will be negative 1 over 1. So it will be negative ln 1 minus R. So we start with the first random number, I equal to 1. Here is I. I equal to 1. So here will be S1 negative ln 1 minus R1. So applying R1 is given 0.1306. Okay, so press calculator, you will get 0.1400, round to 4 decimal places here. Then I equal to 2. So here will be R2. So applying R2, 1 minus by R2. Okay, so equal to 0.0431. Okay, so given R3 equal to 0.6597. So quiz number 3, find S3.